Alright, so today we're going to talk about what are piecewise functions. Piecewise functions are basically a couple of functions, multiple functions put together. I'll give you kind of an example of where they might kind of come into play or be used. If you're taking medicine, so you pop a pill or something like that, right away, let's say it's 500 milligrams or something like that, you're going to have that amount of medicine in your bloodstream. Okay? As it gets absorbed, that amount of medicine in your bloodstream is going to go down. So you might have something where it started up here, and that medicine amount is kind of dropping and dropping and dropping. And then what happens is, it's 4 hours later or towards later in the day, you've got to take another pill. So you put another pill in, and all of a sudden, up jumps your amount of medication in your bloodstream. And then it starts to kind of come down again, and it kind of repeats. Take another medication and comes down. So the idea of piecewise is that they're kind of broken up into sort of different segments. And we're going to see some examples of different graphs. We're going to look at an absolute value function that is kind of defined by a piecewise function. So again, piecewise functions, kind of multiple functions kind of put together, allows you to kind of graph some more real life data. Alright, so for starters, we're going to ask you to graph the function f of x. When we talk about piecewise, we use this kind of brace to kind of represent, because we're going to have multiple functions. So we're going to look at the function 2x. And 2x, again, it's broken into a couple of functions. 2x is going to be our function for x values that are less than or equal to 1. Okay, so we're only going to graph that function for values smaller than 1 or equal to 1. The other function we're going to use is negative 3x plus 2, and that's going to be for all values where x is greater than 1. Okay, so here's our piecewise defined function. In this case, we're going to start out pretty simple, just two linear equations. As you get through the course, you can do tougher functions. Alright, so we're going to sketch a graph, see what this looks like. So for starters, we're going to graph 2x. 2x, I'm going to kind of make a little bit of a table here, so x and 2x. So we're going to use only x values that are less than or equal to 1. So I'm going to use 1, 0, negative 1, kind of go backwards a little bit. When x is 1, 2x is 2. When x is 0, 2x is 0. When x is negative 1, 2x is negative 2. So I'm going to plot those points. Negative 1, negative 2, 0, 0, 1, 2. And again, the graph only exists for x values less than or equal to 1. So my graph is going to be something like that. For the second graph, negative 3x plus 2, again, kind of thinking about a table, negative 3x plus 2 and x. I can't really use 1. Remember when we used to graph just inequalities on a horizontal number line, if it was equal to, we had that solid circle, which we have here. If it didn't have that equal to, that's what we're going to use that open circle. So that's what we're going to do here. So I'm going to kind of act like it starts at 1, 2, and 3, kind of get a couple of points. So at 1, negative 3 times 1 is negative 3 plus 2 is going to be 1. There's going to be negative 1. So I'm going to plot that point, 1, negative 1, but I'm going to use that open circle idea there, because that point actually doesn't exist. This function is not defined at 1. We're going to use 2, negative 3 times 2 is negative 6. Negative 6 plus 2 is negative 4. We can use that idea of slope. We're going to go down 3 more, so we should be at negative 7. So plot that, 2, negative 4, so write 2 down 1, 2, 3, 4. And then if I went over 1, down 1, 2, 3, I get my graph. And so here's my graph of the function f of x. What have I graphed? I've graphed the equation 2x, which is a line that goes through 0, 0 with a slope of 2, but it's going to stop at 1. The graph is only going to exist for x values less than or equal to 1. Second graph is negative 3x plus 2. So it would look like a graph that actually went through 2 and went down 3 and over 1, but the graph doesn't even start to exist until we get to an x value of just past 1, which is what that open circle kind of represents. Okay, so there's basically kind of how we graph piecewise functions, really using this domain restrictions to help us sketch the graph correctly. And again, remember open circles and closed circles, just like you used to do on graphing horizontal or inequalities on a horizontal number line. All right, so next piece we're going to connect this to is then with absolute value. An absolute value graph something like y equals the absolute value of x is actually a piecewise function. When we look at the graph of this, it's a V shape. We can get that by kind of thinking about a table, x, y, -2, absolute value of -2. -2 is 2 away from 0. Remember, definition of absolute value is the distance the number is from 0. So absolute value of -2 is 2, -1 is 1, 0 is 0, 1, 1, 2, 2. So again, if I plot those, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2, what do I get? I get a V. So what do I really have here? I really have two lines. I've got this line, which is actually the line y equals -x, or y equals the opposite of x. And I've got this line y equals x. Okay? And so that's what this is. The absolute value of x is really defined by a piecewise function. What do I get? Well, when you start with the right side, when I put in a number, like 1, I get out 1. I put in 2, I get out 2. So what this does is it graphs x for all x values greater than or equal to 0. So that's going to define kind of this right side piece. It's going to define these points here. For the other part, this is the graph of y equals -x, or the opposite of x. Why? Because when you put in -1, what does the function do? Well, the absolute value actually spits out the opposite of what you put in. So this is going to be the opposite of x. And that's going to be for x values that are less than 0. Okay, so when you put in a negative, basically a number less than 0, what does the function absolute value of x spit out? It actually spits out the opposite of the value you put in. So when I put in -2, this function says, oh, -2, that means I'm down here. When x is -2, what do I spit out? Well, it spits out the opposite of -2, which is 2. So that's why you get the point -2, 2. Okay? So what we're going to work on now is we're going to work on taking a absolute value equation and trying to write the appropriate piecewise function that it's defined on. The big, tough strategy we're going to look at is we've got to find sort of where this V is, where that vertex is, okay, where the graph comes in and changes direction. Basically, what's the x value where the graph changes the domain, okay, where that domain restriction has to be. And I'm going to show you how to find that using the equation given to you. Alright, so we're going to look at given f of x equals the absolute value of 2x plus 1 minus 3, write it as a piecewise function. So we're going to write this equation, the absolute value of 2x plus 1 minus 3. We're going to write that as a piecewise function. Okay? So here's how we're going to do it. So f of x is equal to, and it's going to have two parts to it. The first part, if we remember back to that definition of absolute value of x equal x, provided that x was positive. So we're going to look at if x is positive, basic essence, if this piece in here is positive, or 0, greater than or 0, missed that part. Then the function just graphs itself. So we're going to get 2x plus 1. And we're going to get 2x plus 1 provided that, oh, and then that's this part here, and don't forget the minus 3 on the end, as I almost did. Okay, so we're going to get this absolute value is just going to spit out itself if it's positive, and then we're going to have to subtract that 3 on the end. So if this is positive, well, it's going to be positive or greater than or equal to 0 when this is greater than or equal to 0. So our kind of domain restriction is going to be when 2x plus 1 is greater than or equal to 0. So that's going to be our first part. And we'll kind of simplify this down as we go. The second part is the other part of the definition. Well, what if what's inside the absolute value is actually negative? What does the function do? Well, it takes that value and makes it the opposite. So it takes the opposite of x. Okay? But what's x now? Well, x is what's inside the absolute value. What's inside the absolute value is that 2x plus 1. So what do we get? We get the opposite of 2x plus 1 minus 3. And that's going to work for our other part of our domain when 2x plus 1 is less than 0. Okay? So there's our equation. Now all we need to do is really just simplify this.
Will the custodian please report to the band room? A custodian to the band room.
Sorry for that interruption. Alright, so here we go. So simplify. There's no multiplier out in front, so I can just drop the parentheses here. 2x plus 1 minus 3 becomes 2x minus 2. So you get 2x minus 2. And just some basic work here. I'm going to subtract 1. I'll show you that side work here. I'm going to minus 1 to both sides, except for that's a 2, minus 1. You get 2x is greater than or equal to negative 1, and divide by 2. So what happens here? I get x is greater than or equal to negative 1/2. Okay? So that negative 1/2 is going to be that x value where that v, where the graph comes in as a negative slope line, comes out as a positive slope line. Okay? So what does this look like? I'm going to graph 2x minus 2 when x is greater than or equal to negative 1/2. And then for the second part, what do I need to do here? Well, I need to take this negative and distribute it. So that's really negative 2x minus 1 minus 3. Or negative 2x minus 4. So I get negative 2x minus 4. And that's going to be for, again, if I solve this, it would be the same work. That would be when x is less than 1/2. So there's the same graph. So if I graph this, under the restrictions, only graphing this part when x is greater than or equal to negative 1/2. Graphing this equation when x is less than 1/2. What am I going to get? I'm going to get the graph of absolute value of 2x plus 1 minus 3. That's what this equation really is. It's really just two linear equations meeting at a point, specifically the x value of negative 1/2. Okay? So there's a little intro to what a piecewise function is and how we can connect piecewise functions to the definition of an absolute value graph.